Our first topic here is GCF. Do you know what the letters GCF stand for? Do you know how to find one? I didn't hear a yes to that. And so we will, hopefully at the end of the lesson, you will be able to answer yes to that question. And this word right here is going to be a very important word. Do you know what it means to factor? Do you know what it means if I ask you what are the factors of 6? What are they? I have been surprised at the people that could not answer that question. Can you answer the question? What numbers do you multiply together in order to get 6? 1 and 6 or 2 and 3. Those two questions are the same question. To factor means to find what multiplies together. So you have the step-by-step process here in your notes. Let's go ahead and look down here at problem number 1 and see how to factor. Now, we will be factoring many times in the days ahead, and I will always start my factors the same way. The factors of 12 are 1 times 12. That's the first pair of factors. And sometimes people forget that pair. And 2 times what equals 12? And 3 times 4. And 4 times 3 is the same two numbers, just in the opposite order. And so those are all of the factors of 12. What are the factors of 24? Well, I always start in the same way, and I always write them down in order so I don't forget any. So 1 times 24, and 2 times 12, and 3 times? 3 times what? And 4 times 6, and 5 times? Well, nothing. Does 5 go into 24 evenly? To be a factor, it has to go into the number evenly. Okay, that's all the factors. And now we're looking for the GCF. What's the greatest number that is in both of those columns? Nope, there's not a 24 on this side. The GCF is 12. Now, most of the time we're not going to be factoring, well, we're not going to start off factoring numbers. We will factor some of those coming up. But we will be factoring expressions. Now, we have to go over a little bit of vocabulary here. Why is this called an expression and not an equation? An equation has to have an equal sign. I cannot solve this for x because it does not have an equal sign. This is an expression, and what I'm going to do is factor. Factor can be thought of as reversing the distributive property. Is there a number that divides both 5 and 5? The answer to that would be 5. Do both of these have an x? So the GCF is going to be 5x. Now what I'm going to do with that GCF is I'm going to factor that 5x out. I'm going to divide both sides by the 5x, but I don't have another side of the equal sign to divide it out on both sides of the equal sign. It's not an equation. I can't divide it out and cancel it out. I have to pull it out in front. And 5 divided by 5 is 1. X squared divided by an x is x. The 5's cancel. What's 5 divided by 5? I didn't hear an answer to that. Do you know 5 divided by 5 is 1? And so the x cancels out. And so I have done the reverse of the distributive property. If I distributed this 5x into the x minus 1, I would have the original problem back. I am doing a reverse distributive property, the otherwise known as factoring. So let's look at the next one. Is there a number that divides 14, 28, and 21? That would be what? Do all of my terms have a variable? Do they all have an A? No, I cannot factor out a variable because they don't all have a variable. The only thing I can factor out is a 7. It doesn't factor out and disappear. It comes out in front. 14 divided by 7 is 2. The a square is still there. 28 divided by 7 is 4. The a is still there. 21 divided by 7 is 3. Again, this is the reverse of the distributive property. If I distributed the 7, I would get the original problem back. That's all that will factor out. Example number 4. Can I factor a 6 out of all of these numbers? Sometimes people try to factor out a 6, but what would 3 divided by 6 be? That would be a 1/2. We don't want to factor out and get fractions. We want whole number coefficients. So is there a number that divides 6 and 3 and 24? Do they all have a variable? So not only can I factor out a 3, I can factor out a 3x. So I'm going to factor a 3x out of all my terms. This 3x does not disappear. It factors out in front. 6 divided by 3 is 2. Now, what is x to the third power divided by x? I'm going to go back on the back of my paper and make sure you understand that. X to the third power is x times another x. Isn't that the meaning of x to the third power? And if I divide it by an x, that one cancels. And how many are left? That is the meaning of x squared. One of these is going to cancel one of those, and there's going to be x squared left. One of these cancels one of those, and x squared is left. 3 divided by 3 is 1. Well, you don't usually write down the 1. This x will cancel one of those, and one of those will be left. This x is going to cancel that x, and 24 divided by 3 is 8. To check this, you could distribute and see if you came up with the original problem. Would you please see if you can complete problem 5 by yourself? This is the answer that most people in my first period class gave me, but it's not right. Let me rephrase that. It's not finished. Is this what you had? Do you see that all of these still have a common factor? This one has an m, and that one has an m, and that one has an m. Another m will factor out of this. And this m that I'm going to factor out is going to go out in front with the m I already have. And so that will cancel one of those. That will cancel that one. This is 4m times m times m times m. That will cancel one of those. Oops. This is equal to, better form, 5m squared minus 3m minus 4 plus 5m to the third power. This is factored completely. Do all of these have an m? No. Is there any number other than 1 that divides 3 and 4 and 5? No. This is factored completely. The GCF was actually 5m squared. And it says over here on the front of your notes, can I find the front of the notes? When you are factoring out variables, you need to factor out the one that has the largest exponent possible. And so these all at least have an m squared or bigger, so this needs to be an m squared, not just an m, to be factored completely. In problem number 6, what divides 7 and 5 and 2? Just 1. It doesn't really do anything to factor out 1. But do you notice they all have a variable? The GCF here is, do they all have x squared or higher? Does this one have an x squared or higher? No. So I can't factor out an x squared, only an x. This x that I'm going to factor out is going to come out in front. That's going to cancel one of those. That's going to cancel that one. The way you can check is you can distribute that out and see if you have the original problem back. I'm not going to take class time to do problem number 7 because I think most of you know how to do problem number 7. Am I right? Can you do problem number 7 without my help? I have no response. I'll just have to think that you will. Okay, so I need to talk about number 8, though. Would you say that the answer to this is x squared plus 4? Do you square the first one and square the last one and then you're done? That is not correct. Would you please write it down on your paper and put a great big X mark on it so that you know never, never, never to do it that way? Well, I know some of you are sitting there thinking, I thought that was the answer. If I don't do it that way, what am I supposed to do? Well, x plus 2 squared is x plus 2 times another x plus 2. That's what x plus 2 squared means. How do you multiply that out? You can either use a box problem or FOIL. And x times x is x squared. X times 2 is 2x. 2 times x, 2 times 2. Combine these like terms. This is x squared plus 4x plus 4. This is the correct answer. On problem number 9, is this equal to x squared minus 25? Well, no, because minus a minus, that would be plus. So now is it right? No. Write it down on your paper and put a great big X mark on it, because x minus 5 squared is x minus 5 times another x minus 5. That's what it means to square it. You multiply it by itself. So multiply that out with either a box problem or FOIL. when you multiply it out with a box problem or FOIL and combine these like terms, that's what you get for the answer. Would you please multiply problem number 10? Is that what you got for problem number 10? What happened to the 6x? You had a positive 6x and a negative 6x, and that canceled each other out. This is a special pattern that shows up a lot, and we're going to be working with this pattern a whole lot more next week. I just wanted to show you this pattern and also tell you that it is called the difference of two squares. This type of pattern is called the difference of two squares. In math, what does difference mean? Subtract. Well, you can see that the x is squared, but this two squares means this is a square and that's a square. Do you know that 36 is called a perfect square number? Do you know why it's called a perfect square number? What is the square root of 36? 6. If you take the square root of a number and the answer is a whole number, it is a perfect square number. We will be working on this pattern more next week.